Now we're going to talk about topological sorting and strongly connected components in C++, which are two important concepts in graph theory. These concepts are widely used in various applications, such as task scheduling, dependency resolution, and cycle detection. Whether you're a beginner or looking to reinforce your knowledge, this comprehensive tutorial will provide you with a solid understanding of topological sorting and strongly connected components in the context of C++. Now before we start coding, let's understand the concepts behind topological sorting and strongly connected components. Topological sorting is a linear ordering of the vertices of a directed graph, where for every directed edge uv, vertex u comes before v in the ordering. Strongly connected components are subsets of a directed graph in which there is a path between every pair of vertices. These concepts help us understand the structure and dependencies within a directed graph. Let's begin by implementing topological sorting in C++. And this code will be in the description if you want to follow along in your IDE or Replit. In this code snippet, we define a graph class that encapsulates the functionality of our directed graph. It has a private member adjList, which is a vector of vectors representing the adjacency list, and then we have three member functions within the graph class. The constructor initializes the number of nodes and allocates space for the adjacency list. The addEdge function adds a directed edge from vertex u to vertex v in the adjacency list. The topological sort util function over here is a utility function used by topological sort here. It performs a DFS traversal, marking visited nodes and pushing them onto a stack. The topological sort function initializes a vector of visited nodes and a stack. It iterates through all nodes and calls topological sort util for unvisited nodes. Finally, it prints the topological sorting by popping elements from the stack. In the main function, we create a graph object called graph with 6 nodes. We add edges to the graph using addEdge, the addEdge function, specifying the source and destination of each edge. To perform topological sorting, we call the topological sort function on the graph object. Finally, we print the topological sorting by popping elements from the stack. Alright, so now let's move on to implementing strongly connected components in C++. And once again, this will all be in the description. So in this code segment, we continue working with the graph class. We add two member functions to the graph class. The DFS util function is a utility function used for DFS traversal. It marks visited nodes and prints them. The getTranspose function returns the transpose of the current graph by reversing all edges. The print strongly connected components function performs the Sarju algorithm for finding strongly connected components. It first fills the stack with the vertices in their finishing order based on DFS. Then it obtains the transpose of the graph, and finally it performs DFS on the transpose to print the strongly connected components. In the main function, we create a graph object called graph with 7 nodes. We add directed edges to the graph using the addEdge function, and then to find strongly connected components, we call the print strongly connected components function on the graph object. And finally, we print the strongly connected components.